Hello and welcome to the CCAC Methane Action Program Background Training video series. My name is Nathan Borgford Parnell. I am the Science Affairs and MRAP Coordinator for the Climate and Clean Air Coalition. In this video series, we will be covering each of the 5 MRAP building blocks in detail, providing important background and context and examples of good practice to help countries begin their journeys towards developing national methane roadmaps and achieving rapid mitigation of methane emissions in support of the Global Methane Pledge. The Global Methane Pledge, first launched in 2021, now includes 150 participating countries working towards the collective goal of reducing global methane emissions by at least 30% below 2020 levels by the end of the decade. The Climate and Clean Air Coalition is a key implementer of the Global Methane Pledge and serves as the first point of contact for the GMP signatory countries. In this role, last year, we launched MRAP as a landing platform for GMP countries to join a collective effort, support the development of national methane roadmaps through a common planning and implementation methodology, and connect to expertise and support from the broader CCAC community. Drawing on the CCAC's decade of experience, MRAP supports the development and implementation of transparent and consistent national methane roadmaps by breaking the process into 5 core building blocks. The program is designed to meet countries where they are and to help them translate their existing commitments and strategies into an implementable roadmap. In this video, we will be going over the first of the 5 roadmap building blocks, inventories. I will now pass this along to my colleague Christopher Malley from the Stockholm Environment Institute to cover building block 1.
Thank you. So, why is building block 1 important in developing a methane roadmap? Well, by having our estimate of methane emissions, we can understand how much a country contributes to global methane emissions. And we know that the Global Methane Pledge is defined as a global target for a 30% reduction in methane emissions. So we need to understand how much an individual country contributes to those global emissions to understand how mitigation in that country could contribute to the Global Methane Pledge target. Within the country itself, it allows us to understand the sources that contribute to national total methane emissions. It allows us to understand how much agriculture, fossil fuel production, waste contribute to national methane emissions, as well as other sources that can be large in some countries, like charcoal production. Having a methane emission inventory that is regularly updated over time provides the basis for monitoring trends in methane emissions. We can understand how methane has changed up to this point if we have a historical inventory from, say, 1990 or 2010. And if we update our emission inventory every 2 years, as we update our greenhouse gas emission inventory, we can understand how methane changes as our climate change mitigation plans are implemented. Understanding how the methane emission inventory is developed also provides the opportunity to get support to improve those methane emission estimates. The Climate and Clean Air Coalition and others are able to provide support to move from the simplest calculation methods to improve data collection, to improve methodologies to allow assessment of mitigation options, as well as historic inventories. So including and evaluating building block 1 in terms of inventories allows understanding of how the emission inventory can be best improved. So when we think about developing our methane roadmap, how can we include building block 1 within it? So we've got some best practices here. Lots of countries, including Ghana, shown on this example, have quantified and reported their national total methane emissions within their reporting to the UNFCCC. So we have lots of examples of good practice. First, we need to report our methane emissions disaggregated into IPCC source sectors. This allows us to understand the national total emissions and the contribution that each sector makes to it. We need to report our emissions in tons of methane in order to be able to understand how it contributes to the Global Methane Pledge. which is defined in terms of tons of methane. If methane emissions are reported in carbon dioxide equivalents, then the global warming potential used should also be reported to allow it to be converted back into tons of methane. To understand the limitations of the approach used to quantify methane emissions, the methodological tier used, whether it's tier 1, tier 2, tier 3, should be reported ideally alongside the activity and emission factor data so it can be identified where the uncertainties are and how they could be improved. Reporting as long a historic trend as is available is really useful to see the direction of travel, where methane emissions are going. We can see in this example for Ghana that methane emissions are reported from 1990 to 2019. That shows very clearly and transparently how methane emissions are changing alongside other pollutants. And as I mentioned, including details of the activity data and emission factors provide the maximum transparency as to how those methane emissions have been estimated. As I say, reporting the methodology that has been used to estimate methane emissions is important. In the majority of countries, one of the Intergovernmental Panel on Climate Change, the IPCC, methodologies will have been used to estimate methane emissions. These range from the simplest tier 1 approaches, where typically we're multiplying activity variables, for example, the number of animals, by a default emission factor, the methane emission per animal, provides us with a tier 1 estimate of methane emissions. As we move to the more complex methodologies that the IPCC outlines, the tier gets higher. Tier 2, tier 3 approaches have more detail, more disaggregation of emissions, and where available, the use of country-specific emission factors. Reporting within the methane roadmap, the tier that is being used, allows you to identify where are the sectors that have the largest methane emissions and therefore should be estimated as key categories with the highest emission tier, and where are those sectors that could most benefit from support and data collection and improvements in methods to move from one tier to the next. There are lots of places where you can typically find information that can be useful in integrating building block 1 into your national methane roadmap or action plan. There will be national sources of data. Your greenhouse gas emission inventory, included in biennial update reports, national communications, can provide the methane emission estimates that have gone through that process in developing those reports. Where those are not available or for validation or comparison, there are international sources of data that can be used to provide a comparison or to provide an understanding of the methane emissions. The EDGAR emission database, developed by the Joint Research Centre of the European Commission, and the community emission database that has been developed as part of a community effort to improve emissions, are two sources where you could get international data on methane emissions for your sector. I'd like to finish this analysis of building block 1, or introduction to building block 1, by highlighting a couple of examples of countries that have robustly reported their methane emissions. Here we have South Africa's National Emission Inventory Report from their 4th biennial update report. We can see here that national total emissions of methane are reported between 2000 and 2017, showing a slight increase, and they're reported in gigagrams or 1,000 tons of methane, in addition to carbon dioxide equivalent. So these emissions are directly comparable with emissions from other countries because they're reported in the mass units of methane. We also find methodological detail. In addition to outlining whether Tier 1, Tier 2, Tier 3 methodologies are used for each sector, they report in the annex of the National Inventory Report the actual data that is used as the basis for these emission estimates. So we have here an estimate of the organic fraction of waste in municipal solid waste, industrial waste, and wastewater. We have methane generation rates and correction factors that have been used. This allows us to replicate the methane emission estimates estimated for South Africa, making them robust, but also where develops an understanding of where these emissions methodologies could be improved because default international data have been used. There is plenty more information on methane roadmap developments from the Climate and Clean Air Coalition. Thank you very much.